Welcome back, everyone. Our next talk is going to be with Gajendra Deshpande. Gajendra has studied computer science and engineering, as well as cyber law and cyber forensics at the National Law School of India University in Bangalore. Gajendra is also a GitHub certified campus advisor, and he leads the PyData Belgavi chapter, as well as the OWASP Belgavi chapter. So Gajendra is very busy, has a lot to do. Today, Gajendra is going to be presenting about security considerations in Python packaging. Python's one of the fastest growing programming languages, and this popularity also makes Python a popular target for attackers. In this talk, Gajendra is going to address security issues related to Python packaging and possible solutions to make Python packages more secure. This is a super relevant talk given how much focus we've seen on supply chain attacks over the past few years, so really excited to hear about it. Gajendra, please feel free to take it away.
Thank you. Hello, everyone. Thanks for the nice introduction. So, pardon me for my voice because it's night time, midnight in India. Uh, so, in today's talk, I'll be speaking about the importance of a secure package and vulnerabilities in Python package index. Then we will discuss about three tools. One is Bandit for identifying common security issues in Python code. Then second one is safety for checking the dependency. Then third one is Semgrep, which is used as a static analyzer. Then finally, general guidelines for secure coding practices in Python. So now on this slide, if you see, it is showing the TOB index for Python. So uh, if you are aware, then or if you are not aware also, then TOB is the website which basically ranks the programming languages based on the popularity. So if you look at the popularity here, the popularity of Python is growing over the years, and in 2021 it has reached the top position. And apart from TOB index, there are few more surveys which are conducted, and even here you can see here that Python is ranked third. Of course, if you consider the first two, Python is in a different space. Okay, but uh, in Stack Overflow, based on the popularity, it is ranked third. And similarly, if you look at the statistics on GitHub, right? So number of active repositories, if you see, based on this parameter, Python has been ranked third. So above Python, we have Java and JavaScript. Now this the same popularity is creating a problem. So because of this popularity, more and more hackers are targeting Python and its ecosystem for malicious activities or even to hack the packages. Now let us see open source and some security issues and some misconceptions. So there is a misconception about security of open source software. Of course, um, it's not there with respect to if you are experienced programmer, you know how open source softwares are created. But it's a general misconception who lack the experience and who don't understand the open source ecosystem. And the major reason they cite is that the code is open source. So code is open source, entire the folder structure is visible. So that's the reason they cite. But generally, if we consider open source softwares are secure, say for example, Python is a secure language, we can say. Similarly, Django, frameworks like Django, Flask, they are secure. Even softwares like WordPress, which is used as a content management system, is secure. But the security issues are mostly due to the lack of understanding of secure coding principles. This is one issue. And second major issue is that Python or any open source software is secure, but the vulnerabilities are present in the packages because these packages are many times developed by third party developers. So, who lack the understanding of secure coding principles. So, generally, security is a different domain, coding is a different domain. Okay, so developers need to adopt the secure coding principles in order to make their packages secure. Then importance of secure package. Insecure package will make your application vulnerable and prone to external threats. Compromised and unauthorized disclosure of information may result into personal and company reputation and money. So it may cost on all these three parameters. Then unsecure code may damage the systems of users. Then sometimes it may also lead to physical damage. Now on this slide you can see that there are some articles I have listed. Say for example, Ports Figure has written an article where dependency confusion attack was mounted via PyPy repository. PyPy is the site which hosts all the Python packages. Then JFrog detected malicious PyPy packages, stealing credit cards and injecting the malicious code into Python packages. Then Python PyPy repository vulnerabilities were discovered, and the article was written by developer.com. Then it was also uh, the potential remote code execution was also possible on PyPy index. Then supply chain flaws were found in the Python package repository. So these are the few articles, but there are many more. If you Google, you will come to know about more details. Now let us discuss few tools which will help us to secure our uh, Python packages or even our Python ecosystem. So first one is the Bandit. So it's a tool designed to find common security issues in Python code. So to do this, Bandit processes each file, builds an abstract syntax tree from it, and runs appropriate plugins against the AST nodes. So once Bandit finished scanning all the files, it generates a report. So you can install it using pip command, and there are many options such as -r where you can supply the code repository as input, and Bandit will scan the code repository for common security issues. So first one, as we have discussed, is the -r. So this repository can be local on your machine or it can be remote. So you can also specify a GitHub repository path here, and it will scan the repository, and if there are any security issues, it will generate a report. Then you can also run Bandit with a specific profile. Say for example, here I want to scan for all the files in the examples directory with a shell injection profile. So profile can be specified with -p switch. Then you can also run Bandit with a standard input. So for example, you can use a cat command to display the content of the file and supply that input to Bandit. Now Bandit allows specifying a path of a baseline report to compare against using the baseline argument. So this is a very useful feature because it is very useful for ignoring the known vulnerabilities. That is because we are testing the software. When we are performing the unit tests, uh, the clear text password can be visible. But if you are going for production, then the password needs to be mapped to certain characters such as star. So you can basically ignore the known vulnerabilities, or you can basically ignore the warnings with baseline option. So to generate a baseline report, you can simply run Bandit with output format, which can be set to JSON file. And you can also specify the output file. Now, Bandit also allows you to create your own custom tests. To write a custom test, first identify a vulnerability to build a test for and create a new file in examples folder or in any folder. Examples is just a example. So you can select any custom folder name here that contains one or more cases for that vulnerability. Consider the vulnerability you are testing for and make the function with one or more appropriate decorators. So you can use add checks call or add checks import and import from and add checks string depending on your requirement. Then create a new Python source file to contain your test. Then the function that you create should take a parameter context. So this context is nothing but an instance of the context class. You can query for information about the current element being examined. So you can also get a raw AST node for more advanced use cases. So that you can specify in context.py file. Then extend your Bandit configuration file as needed to support your new test. Exit, execute, execute Bandit against the test file you defined in the examples folder or whatever custom folder, and ensure that it detects the vulnerability. Then consider variations on how this vulnerability might present itself and extend the example file and test function accordingly. Now Bandit has several plugins and these plugins are grouped into certain categories and each group is assigned an ID. Now, for example, in B1 series, we have got miscellaneous tests. On next slide, we can see what are the tests covered under B1 series, B2 series, and up to B7 series. So B2 series consists of application or framework misconfiguration tests. Then B3 series consists of blacklists which are related to calls, and B4 series consists of blacklists which consists of imports. Then B5 series consists of cryptography tests, and B6 series consists of injection related tests. Then B7 series consists of cross-site scripting related tests. So on this slide, you can see that there are some of the tests which I have listed. Say for example, in case of B1 series, we have some test plugins such as set bad file permissions. Then it also checks whether password string is hard coded, whether its password is function argument, and whether the default password is set, and so on. Then similarly, with respect to B2 series, it checks whether the flash debug true flag is set. So we know that debug flag needs to be set to false when we are in production environment. When it is in test environment, it is fine. You can set it to true, but in production environment, it should always be set to false. That's because if you enable debug option to true, then it may also display some errors. And errors usually consists of system information, and this system information can be used by hackers to hack the package or hack the software. So in that case, you have to set the debug option to false, and instead of displaying system errors, display custom error messages. Then in B5 series, you can see that there are some test plugins related to certificate validation, then SSL related test plugins. So SSL related plugins are checking whether it's a bad version, whether the no version, or whether some bad default values are set. Then also it's also checking whether the cryptographic key is weak. Then in B6 series, there are some test plugins related to shell, and in B7 series, there are some test plugins related to say Django. So it is checking whether Django mark safe and use of uh, make templates. The next one is the safety check. So safety checks your installed dependencies for known security vulnerabilities. So by default, it uses Open Python vulnerability database called as SafetyDB, but it can be upgraded to use PyApp.io safety API using the hyphen key option. It supports Python version 3.5 and above. Now, interestingly, if you want to demonstrate the usage of safety command, there is a package called as insecure package. So you can install it and check whether your safety command is working properly or no. Now, to check the currently selected virtual environment for dependencies, you can just simply say safety check. Then you can also check for the packages which are mentioned in requirements.txt file using -r switch. Then there are some examples where you can read the input from the standard input. So that is supply the output of or the content of requirements.txt file to safety check. Then you can also use pip freeze command. So basically pip freeze command can be used to check the current environment. Okay, so you will get the list of all the packages which have been installed using pip command. Then you can also check for specific packages. Say for example, here I am checking insecure package whether it is safe or unsafe. Then this is how you run your software, that is safety check, and you will get a report. It shows which version is installed and which versions are affected. So basically it says that URL lib3 1.26.3 is installed, and it says that versions greater than 1.26.0 and less than 1.26.4 are affected. So the solution is to upgrade the package to the most recent version. So that may solve issue in most cases. So this is the same example which has been run when or after installing insecure package. Then SafetyDB. So SafetyDB is a database of known security vulnerabilities in Python packages. So the data is made available by PyUp.io and it is synced with the repository once per month. So most of the entries are found by filtering CVEs, that's the common vulnerability database, and changelogs for certain keywords. Now, this statement is very important, that the list is not a deny list or package to be avoided. So just because a particular package is present or its entry is present in PyUp.io or SafetyDB, you should not be avoiding it. You should see what kind of vulnerability it is, then take a call. So if the vulnerability is known or which can be ignored, then you can continue using it, because you will also see there that many popular packages are listed. So just because it is present in this database, you should not consider to avoiding it. So you can use it, but you can examine and then take a call. Then you can visit this link pyup.github.io-safety db. So you will find the list of all insecure Python packages. Now SafetyDB provides two files. One is insecure.json and second one is insecure full.json. The first one, insecure.json, just contains the package name and all insecure releases of a package, whereas the second option will also give you the description, CV description, and the URL. So depending on your requirement, you can start using or start referring the particular JSON file. Then SafetyDB also provides some tools. So one is the Safety CI, which is a deep GitHub integration that's available on pyup.io. It checks your commits and pull requests. Then safety command, we have already seen it. Then you can also use safety with Django. So that wants if there are If there is any Django release is insecure, then safety bar, it's a Mac OS menu bar application, which is a very minimal application. Then a pre-commit hook is available. It checks your Python dependencies against the safety DB. Then ppnv check relies on safety and safety DB to check for known vulnerabilities in locked components. Then the final tool which we are going to discuss is the Semgrep, that is the open source static analyzer. So it's open source and works on 17 plus languages including Python. So it's a very wonderful tool. You can search in the YouTube. Lots of very good tutorials are available on Semgrep. So it works with other languages also. And the important thing here is that it is not vendor controlled. So 1000 plus rules have been written by the community members, and it enables you to write your own rules. And the rules also look similar to the code. Results are available on the terminal or editor or in the CI/CD pipeline. It addresses OWASP top 10 issues. Then it hunts vulnerabilities by iteratively exploring a code base with lightweight queries. Then I have included a link of a playground. You can just click on the link or go to the link and start exploring the Semgrep tool. So you need not have to install it. You can experiment online. Select a language, select other options and see how it works. Then finally, general guidelines. If you are a package maintainer, then ensure that the package you are maintaining is secure and practice secure coding. Now, these guidelines are not only specific to Python, they are true for any open source software. Now, as an application developer, follow secure coding principles while writing code. Then use tools to check vulnerabilities before using them in your projects. Now we have just discussed three tools, but these are not the only available tools. There are many more tools. Depending on your requirements, you can start using or start exploring the tools. Then periodically scan your environment. Now after installing a package also you can scan. Before installing the package also you can scan. Okay, then sign and verify package using PGP keys. Then use Twine for improved security and testability. Then scan packages before upgrading. Then ensure that you install code from trusted source. That is, if you are installing a code from repository, ensure that it's the code created by the creator and it's the trusted package. So don't install code from some unrecognized resource or unauthorized resources. So always install plugins from official source. Thank you everyone. I hope you have enjoyed the talk. If you have got any questions, I am open to questions.
Awesome. Thank you so much, Gajendra. I think we can all feel safer knowing that we have all of this guidance on how to make sure that we're using the correct code within our Python projects and all of those tools that you gave us to check the safety and security of our different packages. It's going to be super helpful. So much appreciated.
Yeah, thank you.
All right.
I enjoyed giving talk at PyCascades.
Yeah, I'm glad. And I think you're joining us from India. Is that correct?
Yeah, correct.
All right, so it's very late at night there. So thank you again for joining us at this time of night. That's much appreciated. Gajendra will be doing a Q&A for us in the Q&A room, so please feel free to join over there. And then, of course, don't sleep on our Microsoft and PyLadies booths. They are both there for you to learn more and talk and all of that good stuff. We'll take a quick 15-minute break, and then we'll be back for, I think, our last talk of the day. Thanks, everyone.
Thank you. Bye.